Alright, so let's go ahead and put everything that we have learned together in this video, alright? So let's identify everything. So let's go ahead and just start maybe something like this. Let's say this is, we have x plus 1, x minus 1, and x minus 6, all divided by x plus 2, x plus 1, and x plus 3. So we want to identify, this problem is asking us to find the wholes. Okay, we want to find the wholes. We want to find the x-intercepts. We want to find the vertical asymptotes. And we want to find the horizontal. Okay, I know I spelled it pretty bad. I'm getting used to this here. So, wholes, do you notice anything that's the same top or bottom? Well, I notice x plus 1, x plus 1, right? So we can cancel these out, and I'll go ahead and write it here. X plus 1 equals 0. Subtract 1 on both sides. So one of my wholes is x equals negative 1. Okay, well, let's just rewrite this as then x minus 1, x minus 6, all divided by x plus 2, x plus 3. Okay, so find my x-intercepts. I set the numerator equal to 0, and I'll set those individually. And so we're going to get x is equal to 1 because we're going to add 1 to both sides, and x is equal to 6 because we're going to add 6 to both sides. Vertical asymptotes at the bottom equal to 0. Again, do the same thing. Subtract 2 to both sides, and we're going to get that x equals negative 2. And over here, we're going to get x is equal to negative 3. Okay, you can see I'm doing these rather quickly now. Found my wholes, x-intercept. Now to find my vertical or horizontal, I'm just going to focus on, remember the degree, the top. So on the top, we're going to get x squared divided by, and on the bottom, we're going to get x squared. All right, well, as x approaches infinity, or negative infinity, right? Well, this is same on the same variables, top or bottom. They're going to cancel, and you're going to get 1. So my horizontal asymptote is y equals to 1. Cool. That's a quick example of one and already in factored form. Maybe let's do one that's a little bit more challenging. Let's say we have y is equal to, let's say, x plus 0.5. And then over here, we're going to get x squared minus 4x minus 32, all divided by, let's do x squared minus 9. And then we're going to get x plus 0.5. All right, so before we proceed, before we do anything, we want to get everything into factored form, right? Because I want to see if maybe there's anything else. I know that there's going to be a whole here, but I want to maybe cancel everything. So let's write all the factors of 32. We're going to get 1, 32, 2, and 16, and 4 and 8. And I can already see after writing these down, this is not going to work, this is not going to work, and we're going to be able to use 4 minus 8. So I know on the top I could rewrite this whole thing as x plus 0.5, x plus 4, and x minus 8. On the bottom, we have x squared minus 9, right? Well, I'll write that as x squared plus 0x minus 9. Write all the factors of 9, 1, 9, 3, 3. So, well, 3 minus 3 gives me the 0. And so I'm going to get x plus 3, x minus 3, and x plus 0.5. Okay. Again, you can see negative 8 plus 4 gives me negative 4. Multiply them to get negative 32 here. 3 times negative 3 is negative 9. Add them gives me the 0. So now that I have everything in factor form, I'm looking to see does anything. Now let's go ahead and officially identify my wholes, right? Let's officially identify the wholes of the function. Well, I notice this is the same top or bottom. So we're going to get x plus 0.5 equals 0. Subtract 0.5 to both sides. And we're going to get that x equals 0.5. Oops, negative 0.5, I should say. All right, well, I'll just rewrite this so that it's nicely organized. X plus 4, x minus 8, all divided by x plus 3, x minus 3. Well, to find the x-intercepts, I set the numerator equal to 0, so we're going to x is equal to x plus 4 and x minus 8. Here we're going to get x is equal to negative 4. And here we're going to get x is equal to positive 8. Over here for the vertical asymptotes, we're going to get, well, 0 is equal to x plus 3 and 0 is equal to x minus 3. And so we're going to get x equals negative 3 and x is equal to positive 3. Okay. Now to find the horizontal asymptotes, well, we're going to get, on the numerator we have xx, so we're going to get x squared over x squared, and as x goes to infinity, like the previous example, it's just 1, so y is equal to 1. Perfect. And there it is. That is the situation we dealt with. So, alright, let's go ahead now, and let's maybe do an example like this here that's a little bit more challenging, and this is kind of exceeding level, I would say, on a test. Let's say we have x to the third minus 12x squared plus 47x minus 60, all divided by, well, x minus 3 and x squared minus 4. Alright, so I want to turn the top into, and let's say I tell you here that a factor, well, I don't actually want to say it, right? Let's just, what you can do is you can type this numerator equation into your calculator to find the roots, but the hint is that one of these is probably the factor of one of these, so we can go ahead and maybe give it a try and see exactly what's going to happen, right? So I want to turn the top part into factored form, right? I want to turn this whole thing, so we're going to get 0 equals x to the third minus 12x squared plus 47x minus 60. And let's say that I tell you that a factor is this right here, x minus 3. So it's kind of a hint, or I kind of give it to you on the test that x minus 3 is a factor. That means that the root is 3. And we need to use synthetic division to turn this into factored form. Okay, well, we bring the 1 down. 3 times 1 is 3. We're going to add them and get negative 9. Then we get negative 27. Add these and we're going to get 20, and 3 times that is negative 60, so we get 0. So now we can rewrite the bottom equation as, well, 1x squared minus 9x plus 20, because this is x to the third, this is going to be 1 less. So now we can rewrite, alright, now let's find all the factors of 20, 120, 2, 10, and 4 and 5. Well, if I make both of these negative, they'll add up to give me negative 9 and positive 20 when you multiply them. So now I'm going to rewrite the top. We knew 3 was a root, so x minus 3, and we're going to get x minus 4 and x minus 5 on the numerator, and on the bottom we're going to get x minus 3. Let's solve for this here. This is x squared plus 0x minus 4. So hopefully by now we're pretty good with these, and we're going to get x minus 2, x plus 2. All right. So we had to turn this whole thing to factor form again, because this is degree 3. We do need to have 3 factors on top. So don't forget, right? You might end up writing over here the factored form of this. Oops. Let me scroll down. The factored form for this right here will be x minus 4 and x minus 5, right? Negative 5, negative 4 give you negative 9, and multiply to give you 20. You might write these two, but you cannot forget this third one there. Now that we have this here, now let's ask ourselves, is there anything on top or bottom where we're going to get a hole? Well, we are going to get a hole right here. So let's cancel these out. So holes. We're going to get x minus 3 is equal to 0. We add 3 to both sides, and we get x is equal to 3. So that's a hole. Now let's find our x-intercepts. Okay, I'll just rewrite this once we've canceled them out as x minus 4, x minus 5, as x minus 2, and x plus 2. X-intercepts are 0 equals x minus 4 and 0 equals x minus 5. So x equals 5 and x is equal to 4. Well, that's great. And now we find our vertical. And the same thing on the bottom. X minus 2 and 0 is equal to x plus 2. Subtract 2 to both sides. X equals negative 2. And here we're going to just get x equals positive 2. Well, again, x times x gives me, for the horizontal asymptotes, I'm going to get x squared over x squared. As x approaches infinity, we're just going to get 1. So our horizontal asymptote is y equals 1 over here. All right, and then we're done. All right, well, let's just go ahead and maybe look at an example problem. Let's say, this is just a random note, but let's say we have y equals, let's say we have 2x squared plus 1 over 2x squared minus 5, all right, plus 2. And we want to identify the horizontal asymptotes, right? Well, as x approaches infinity, right, we just look at the numerators here, we're going to get 2x squared over 2x squared. But don't forget that there's this plus 2 there, right? And so as we plug in big numbers, these are going to cancel out. 2 divided by 2 is just 1, so we get 1 plus 2, which is 3. So my horizontal asymptote is y equals 3, right? A little bit of a challenge because now we have this plus 2 here on the outside. And so this is going to cancel out. 2 divided by 2 is 1, so this whole thing becomes 1. And 1 plus 2 gives me 3, all right? And you can see that, again, when we're doing this, as x gets really big, we're basically ignoring these right here and just focusing on the highest degree there. All right, so hopefully that's going over one example of horizontal asymptotes, the different kinds that can arise. Let's look at maybe one more. Let's say we have x plus 1, x plus 2, and down here we have x to the third plus 4x plus 2. Well, if we want to find the horizontal asymptotes, well, on the top we have x squared, and on the bottom we have x to the third, right? We can ignore this, and we can ignore the plus 1, but we still have this plus 2. All right, now as x approaches infinity, well, what's going to get bigger, the top or the bottom? Well, the bottom one gets bigger, so this whole thing is going to become smaller and smaller until it gets 0. So we're going to get 0 plus 2, which equals 2. So my horizontal asymptote would be y equals 2. All right, this is just two examples of horizontal because we didn't really go over some kind of challenging ones, but that's kind of how you would go about doing it. Thank you.